So in this video, what we're trying to do is we're trying to solve for this problem where we have, if you imagine, Messi on the top of the Eiffel Tower who is about to hit a ball horizontally with some velocity. And we're trying to figure out when the ball hits the ground, how far it is from the base of the tower. So we're trying to see how further from the tower can Messi hit the ball. Now, what are our knowns? So we know that the Eiffel Tower is, as of 2022, is about 330 meters high. So we can imagine that to be that distance. And we know Messi, being a very accomplished football player, is capable of hitting the ball at about 144 kilometers per hour. That's his shooting speed, or what we can also write as 40 meters per second. And we are asked to find what this distance is going to be. So, what do we know? We know the equations of motion. We know the three equations, which I'm going to state here. So, v of t equals v at time equals 0, plus the acceleration times the time. Second equation is the displacement at t equals the initial velocity times time plus half a t square. And the third equation, which is the velocity squared at time t equals velocity squared at the beginning plus 2 times a dotted with the displacement vector at time t. So, which equation should we use to solve this problem? Imagine, if you will, that the ball goes from here down to there and all the way down to there. And at this point, let's say this happens at time t equals t, this at time t equals 0. We can draw a vector. We can draw a displacement vector that goes all the way from the initial position of the ball to the final position. So we might as well just use this equation, right? So what we can say for this equation, the second equation at time t equals t, where we assume that the ball is eventually going to hit the ground, we can say that s of t equals the initial velocity. We know that the initial velocity is going to be 40 meters per second, 0, times the time plus half and the gravitational vector, which is going to be 0, negative 81 meters per second square, t square. Now, how have I written this equation? We have used the fact that the initial velocity vector is always pointing in the x direction. So its vector is going to be 40, 0. The gravitational force is always downward, and we will have a negative value for the y-axis, for the y component of the force. All right, so what can we do now? Well, we can explicitly solve this. We can add the common components that makes 40 t meters per second as the x component, and for the y, it's going to be 0 times t, half times the gravitational pull times t squared. So that will make it negative 1.9.81 by 2 t squared in meters per second square. And that is going to be the displacement vector at times t equals t. So what have we determined from this? Well, we know that at the time at which the ball hits the ground, its x component is going to be given by 40 times t. And that is going to be this value. So incidentally, That is the distance we are looking for. And the y component is going to be this height here, which is given by this term. Now, incidentally, we know that this height is 330 meters. That is the height of the Eiffel Tower. So, what can we write? Well, we can say that 9.81 by 2 meters second square times t squared equals 330 meters. And we can solve this out, cancel out these units. We get the time, or t, as the square root of 330 into 2 divided by 9.81 seconds. And we can solve this to be approximately 8.20 seconds. So this is the time for which the ball that Messi hits right from here is going to be in air for until it hits the ground. And now that we know t, well, we know this term, which is the distance we are looking for, which is equal to 40 times the t that we solved for, and we can explicitly write it here to give 40 times 8.20 seconds, and this is meters per second as the speed, the shooting speed of Messi. And so cancel out the units, you are left with about 328 meters, and that's an impressive distance. It's as tall as 328 meters, as tall as the Eiffel Tower. So that's the impressive distance with which Messi is able to hit the ball further from the Eiffel Tower in the horizontal direction if he hits the ball from the top of the tower at his fastest shooting speed of 40 meters per second. There you go.